Now let's just back up a moment, and I want to consider the neurons that are primarily living now in gray matter and sending out axons in the horizontal direction within the cerebral cortex. Now for these neurons, the story seems to be a bit different, and perhaps it's because in the gray matter of the cerebral cortex, we don't have nearly so much myelin that might be expressing all of these inhibitory signals. What animal model studies suggest are the exuberant growth of horizontal networks within the cerebral cortex following local injury. And so this provides a substratum for plasticity and adaptation following an injury to a region of the central nervous system. And I think from a standpoint of rehabilitation, the outgrowth of this horizontal network following injury provides opportunity to shape that plasticity and to provide the kind of structured patterns of pre- and postsynaptic activity that would align itself with Hebb's postulate and our principles of spike timing dependent plasticity that might produce adaptive change, adaptive plasticity that could lead to the restoration of function. So as we're just now beginning to understand these rules of plasticity and the molecular signaling that can promote growth or inhibit growth, I think we have tremendous potential now to develop strategic interventions that combine physical therapy with pharmacological intervention, perhaps even genetic medicine, as a means by which we can optimize the plastic potential of circuitry within the cerebral cortex to overcome the impact of disorder and disease that may be associated with focal injury. Well, lastly, I'd like to talk about the limited potential of the brain to generate new neurons throughout life. Now, I emphasize limited because there was a time, maybe about a decade ago, where there were numerous studies suggesting that the creation of new neurons from stem cell populations might be widespread throughout the cerebral cortex. Well, through a set of rather compelling studies done in the last 5 or 6 years or so, I think we've settled this question, and we now agree that the production of new neurons in the human brain is really limited to a special set of stem cells that seem to sit in the basal region of the dentate gyrus of the hippocampus. So in this subgranular zone, we have a population of neural stem cells that can differentiate into interneurons that are found in the granule cell layer of the hippocampus. So it's very clear that neurogenesis in the adult human brain does not occur over the entire cerebral mantle, but rather is restricted to this small region within the medial temporal lobe. Now, that's not to say that this is functionally unimportant or clinically insignificant. Actually, quite to the contrary. We now know that this genesis of new neurons in the hippocampus can be modulated by all kinds of different interventions, including pharmacological agents such as antidepressant medications, as well as physical interventions such as exercise. And generally speaking, this is a bit premature to say this, but I'll do it anyway. Generally speaking, as measures of health and wellness increase, so we see an increase in the rate of neurogenesis in the hippocampus, at least as predicted by animal model studies. Conversely, those indicators of a reduction in quality of life, be they disease or be they mental illness such as depression or other modifying variables such as inactivity or sedentary lifestyle, these kinds of factors tend to reduce the rate of neurogenesis in the hippocampus. Now, I don't think anyone really understands why generating new neurons in the dentate gyrus of the hippocampus ought to be associated with health and wellness. But if indeed it is the case, then I think this is actually good news, because it suggests that there may be multiple mechanisms that are available to most of us by which we can optimize neurogenesis in the hippocampus and thereby promote healthy brain function and health and wellness more generally. So, with that said, I look forward to an opportunity to exercise later today or first thing tomorrow morning and maybe inspire a modest increase in my rate of hippocampal neurogenesis. Okay, well, this concludes Unit 5 of the course. So we've now explored mechanisms of neural signaling, we've surveyed our sensory motor systems, and we've had a chance to discuss brain development in early life and how the brain changes across a lifespan. What remains in our course is an exploration of the more complex brain functions that will give us an opportunity to really synthesize and integrate everything we've been learning in medical neuroscience, including the anatomy of the human brain. So I really look forward to getting into the final unit of the course and having these discussions that I really hope will put a bit of a capstone on your experience with me in your studies of medical neuroscience. So I'll see you on the other side of the Unit 5 quiz and look forward to speaking with you in Unit 6 on complex brain functions.